4.3. What we're looking at today for 4.3 is the types of solutions functions have. So we're going to kind of run through a couple things really quick and just see, like, is there patterns that are going on? Is there something that's easy to see? And then go from there. But first, you have your warm-up problem. Try to tackle that. If you want to draw a picture, do that. Just put a little grid right there. Put your end behavior and then answer that. If you don't want to draw the grid, that's fine. But see if you can answer these two problems. I'll give you about 2 minutes.
Why do you have infinity? Okay, that's the ones. Like this.
Yeah, sure. Yeah, sure. Hand it over. All of that's graded. I'm never going to see it otherwise. Thank you.
Because the numbers up here, it's just infinity numbers.
I'll be right there.
Yeah, so I don't get this. I don't get the extra numbers. Like what he's doing, how like it's like extra numbers. Yeah, I don't know how to do those. I don't have to do the simple ones. We just call it the sign. So it's actually pretty easy for the.
It's a good, easy unit to do that for. All right, let's go with Hayden. What'd you write down for the first one?
I wrote down the top positive and down. Wait.
Okay, so this one you wrote positive infinity,
Yeah.
and this one negative infinity. Yeah? All right. Who agrees with that? All right. Don't agree. Why not?
I said I don't know.
Oh, you don't know.
No, I don't know.
All right. All right. Okay, let's pause here. So when I see this, I'm going to tell you right now, you're half right. Okay? So I'm going to erase both of these, but one of them is correct. Now, when I look at this, that doesn't matter. It doesn't matter. It doesn't do anything for the end behavior. You know, in the graph itself, it might make a little squiggle in the middle or something, but it doesn't do anything for what we're doing. This 7 doesn't really matter. It kind of matters in telling me it's positive or negative. That's it. So this is positive 7. So that plus sign is what matters. And it is degree what? What is that degree right there? Not 7. That's right. It's 4. It's the exponent. So it's positive 7, degree 4. So degree 4 and positive goes like that. So it's going to be infinity and infinity. Positive for both. So as I go to the right, this goes up. As I go to the left, this goes up. That's what it's saying. So that's good. What about number 2? Go for it. Negative infinity and infinity. What do we think of that? All right, got thumbs up. For those of you who are unsure, again, this doesn't matter. We don't care about it. What I do care about is the negative. So I got a negative sign right there from the -2. And then what degree is that? 5, degree 5. So that means my graph looks like that. So I 100% agree. Okay? So we got negative infinity going down. To the left, I have positive infinity going up. So that's how it works. All right, any questions there? You had this chart yesterday. It's a pretty helpful chart. Make sure you utilize it if you need to. So, linear functions, I'm going to write one out. Y equals 2x plus 7. What degree is that x right there? 1. Yeah, first. So, degree 1. How many times does this have to cross the x-axis? Once. So, how many real zeros does it have? 1. Does it have any imaginary solutions? No. Okay? No imaginary. We're going to kind of see if any patterns arise, all right? So I'm going to go to the next one. So quadratic, what degree is that? 2, yeah, it's degree 2. So we have 2 examples up here, 2 graphs of it, but I'm going to change it up a little bit. So this is the smallest number of real zeros that could exist. I could have a quadratic that looks like this. How many times did I cross the x-axis?
0.
0. So the smallest number could be a 0. If I have 0 solutions, remember from the fundamental theorem of algebra that we learned about in chapter 3, if it's degree 2, it has 2 solutions. If it's degree 50, it has 50 solutions. So if I have 0 real solutions, how many imaginaries do I have? How many? I need 2. Yeah. Because if I have 0 real, I need to have 2 solutions. I'm going to have 2 imaginary ones. So I got 2 right there. These 2 always add up to whatever that degree is. Now, biggest number of real zeros that could exist. 2 is correct. So I could cross both there. So I'd have 2. And if I have 2 of those, how many imaginaries do I have? 0. Because they have to add up. Is there any other possibility? Could I have 1 and 1? Let's think about that. If I go like this, my quadratic looks something like this. And let's say I actually crossed right there. So I have a dot right there. Is that 1 or 2 solutions? It's actually 2 solutions. It's 2 real solutions. Because an example of this would be x minus 3 times x minus 3. So I have the same solution, but that solution is happening twice. Okay? So we will never have any other option. Okay? We only have these 2 options. I will also throw out there, imaginary solutions always come in pairs. That's why when we did the quadratic formula, whenever you had an I, you always had a plus or minus in front of it. That's always the case. Okay? Any questions about this one? Cubic, what degree is it? 3. So we got degree 3. What's the smallest amount of times this would cross the x-axis? Once. Yeah, it has to cross. It's always going to cross at least once. So if it crosses 1 time, how many imaginary solutions are there going to be? How many? 2. Because these 2 numbers add up to make the degree, which is 3. All right. Biggest number of real zeros that could exist. So 1 cubic I could have is that. That would be like the 1 up here. I could also have something like this. In which case I cross 1, 2, 3 times. So, biggest number of real zeros that could exist is going to be 3. If I have 3 real solutions, how many imaginary do I have? 0. That's right. Good. Now, if imaginary solutions come in pairs, this is the only option that I have for imaginary solutions. So there's no other options. Okay? So we can go to the next. Quartic degree. Four. Yeah. Folks, I don't know if you realize this, but whatever the problem number is, it's also matching up with the degree. We've kind of been working that on. So degree 4. So if I have this right here, I don't have to cross the x-axis. So the number of real zeros that would be the smallest would be 0. If that happens, how many imaginary solutions do I have? 4. Yeah, that's right. Now the biggest number, well, I could look at this one over here, and I could cross 1, 2, 3, 4 times. If that happens, then I would have how many imaginaries? 0. Because again, these always add up to 4. Is there any other possibilities? What happens if I had something like this? I'll draw the graph down here. What if I have this? What would that be? 2 and 2. So I could have 2 real. And 2 imaginary. That would be my other option. Okay? Degree 5. I want you to try to answer this one. Write some stuff down. And then we'll talk about it together, but try to answer it. See if you can. What you got, Jack? Yeah. I like it. Perfect. 1, 4. That's nice. So odd functions need to cross once. Always. Odd functions always cross once. Okay. What's the biggest number of real zeros that we could expect? Anyone? What? 5. Could be 5. If we have 5, how many imaginaries would exist? 0. Yeah. What other options do we have? Other way around. Yep. It can only be one of them, so it can only be 3 real and 2 imaginary. Imaginaries always come in pairs. You never have 1 imaginary or 2 or 3 imaginary or 5 imaginary. They always have to be an even amount. All right. Number 6. I'll draw some possible ones. You can draw them down too. Now, a 6th degree can look like a degree 2. It can look like a normal quadratic. It could look like that. It would be a little more boxy, honestly, okay, but it could look like that. It could also look something like this. It could look like that. And I'll draw one more. Could look like that. And there's tons of different possibilities, like it can look like all these different things. But what's the smallest number of times it has to cross? 0. Yeah, so odds have to cross once. Evens do not have to cross. So this is even, we got 0. So if that's 0, this is 6. If it does cross 6 times, then we have 0 imaginary. What are the other options? Yep, 4 and 2. What else? 2 and 4. Questions? You can flip the page. I'm going to ask you a question though. I have degree 100. How many total solutions do I need to have? Yeah, we need to have 100. Now I tell you that I have 20 real. How many imaginary solutions are there? 80. Okay, so use this knowledge. Now, if I still go like this, x to the 100 plus x to the 10th, you know how many solutions I still have? 100. Okay. This stuff is just extra fluff. Doesn't actually do anything. Now, that's in standard form. We're now going to take a look at factored form. So, oh, I lied. No, we just summarized it. We're good. Okay, so this, if you can find a 0, if you can find a root, you can find an x-intercept, all of those things are the same. If you can find one, write it out, because it will help you. So if I write this down, what's my x-intercept from that? X plus 2 gives me an x-intercept of -2. So I'm going to write that down as -2 comma 0. X minus 3 gives me an x-intercept of +3 comma 0. And then I have this. Now I try to factor it. What multiplies to 9 but adds up to 2? There's nothing. Okay, nothing. But this is what I want you to do then. You got to check. So I'm going to go b squared minus 4ac. What is this? The discriminant. So let's calculate. So I'm going to get in here, that's all I'm looking at right now, I'm going to get 4 minus 4 times 1 times 9, which is 4 minus 36. Stop there. 4 minus 36, is that giving me a positive or a negative number? Negative. Negative numbers from the discriminant mean you have 0 real solutions, which means that you have 2 imaginary solutions. Okay? So now I go ahead and I answer this thing. So to answer how many total solutions there are, I need to know what degree this is. So I go like this. I have 1, 2, 3, 4. I am degree 4. I'm a positive degree 4 because this x, and this x are all positive. And I counted this one twice and not that one because if I distribute this out, if you think about back to the 4-1 homework assignment, if you distribute all of that out, if you multiply just the first terms together, it gives you your biggest exponent. So in this case, our biggest exponent is x to the 4th, and it's positive. So I have how many solutions? 4. So we got 4 solutions. How many of those solutions are real? 2. I had my 2 x-intercepts, so I know I had 2 real solutions. And then I also know I have 2 imaginary, and that checks out because 2 plus 2 gives me 4. So that's good. Okay, lots of little checks in there that you can use. Questions on the first one? Now, I'll point out, number 1 is factored form. Number 2 is standard form. If it is in standard form, you are lucky. You have a lot less work. Because none of this matters. It's just put there. Honestly, it's just a bunch of random numbers. Normally math teachers make your numbers kind of nice, so things work out. We're put really random numbers there because it doesn't matter. They have no bearing on the problem. What degree is this? Degree 7. So it's an odd power. Odd powers have to cross how many times? Once. So the smallest number of times, the least number of times that this could cross would be 1 time. Okay, clean slate. What's the most number of times that this could cross? 7, yeah. And lastly, if g of x had 3 real zeros, how many imaginary solutions would there be? Yeah, 4. That's it. Questions? All right, number 3. So this one's a little bit tricky, but it's really not. So I'm going to do the same thing I did on the last problem. I'm going to kind of expand it out just a little bit. So I have x plus 2 squared. Realize that that just means this. Right? What's my x-intercept from that? It's a negative 2, 0. I put a star by this one because it happens twice. Okay? It's the same thing, but it happens twice. That's actually really important for later on. Now, this next one, x minus 3, what's my x-intercept for that? Positive 3, 0. So I'm going to put that right here. Okay, last thing, what factors to 11? So what multiplies to 11 but adds up to 2? Nothing, but let's double check, okay? So I get 4 minus 4 times 1 times 11. Is that going to give me a positive number? No. 4 times 11 is 44. 4 minus 44, it's not happening. I don't have to keep going. You can calculate it if you want, just to make sure, but it's helpful to see that, so you know. So that means that these solutions are imaginary. Now, folks, we did 2 of these where those were both imaginary. On your homework, you're going to be able to factor it, okay? And it wasn't put there to trick you, but a lot of you are just like, oh, it's always this. It's not always that, okay? So sometimes you got to factor. And if you can factor, you just get 2 more solutions. That's it. So now I go to my problem. And I still have to count up how many x's I got. Now this is x squared, so I go 1, 2, or if I'm up here, I just go 1, 2. Then I got 3, then I got 4, 5. So I have degree 5. Are any of those x's negative? No. So I have all positives multiplied together. So I have positive x to the 5th. Now I look at my questions. I have all my work done. I have all the information I need. So it says, are there any repeated roots in the function? If yes, where? Where's my repeated root? Yeah, right there. I'm going to write the root, though. I'm going to write negative 2 comma 0. You can also say a different way. If it says if, yes, where, I could say at x equals negative 2. And this is actually my preferred answer. Okay? I'm just connecting the coordinate there for you, but that is the preferred answer. Now, on your paper, I believe this says touch. Correct? Yeah. Okay, that's good. So how many times does h of x touch the x-axis? Well, it hits it right here. So that's 1, right? Touches it there. It touches it right here. And then what happens? Do we touch at imaginary solutions? No. So it touches twice. How many total solutions does this have? 5. because it's degree 5. So we have 5. Again, I don't care about that. Okay, so I got 5. How many of those solutions are real? Well, I have 1 solution that's real, 2 solutions that is real, 3 solutions that is real, so I have 3 solutions. One of them we counted twice because it was a double root, it was repeated. How many solutions are imaginary? 2. So folks, this is kind of continually building how we're going to do this, because we're actually going to go and we're going to graph something that looks like number 3. You're actually going to graph it very well. You always pretty much have. So what questions do we got?